So good evening, everyone. We'll start a new chapter, electromagnetism. So listen carefully, children. What do you mean by electromagnetism? What do you mean by electromagnetism? Any idea, Ishida? No idea about electromagnetism. I think in school they completed the portion, right? Joel, any idea?
Sir, it attracts iron particles.
Attract certain particles. That is magnets, right? What do you mean by electromagnets? Children, listen carefully. By using electricity, we are producing magnetism. By using electricity, we are producing magnetism. So this type of magnets or this property, we call it as electromagnetism. Understood? Due to the passage of electric current through a conductor, that particular conductor will show magnetic properties. This is nothing but we call it as electromagnetism. Children, this was introduced by Hans Christian Ørsted. The electromagnetism was introduced by Hans Ørsted. Children, listen carefully. What was Ørsted's experiment? What do you mean by Ørsted's experiment? Any idea? I think I'm audible to everyone, right? Am I audible?
Yes, sir.
Okay. So, why many are joining now? Classes at 8:45, right? So join and log on time, okay? Everyone should log in at on time itself. Understood? Yes, listen. So what do you mean by electromagnetism? I introduce electromagnetism is nothing but you just consider a conductor. Through that conductor, we are passing electricity. When electricity passes through the conductor, it will show magnetic property. It will become magnet. This particular process, we call it as electromagnetism. This was introduced by Hans Ørsted. So he done some experiment. So I'll explain his experiment. Before that, what was his experiment? Children, he explained the magnetic effect of electric current. What do you mean by magnetic effect of electric current? What do you mean by magnetic effect of electric current? Children, this is nothing but you just consider a conductor or a conducting wire. Through that conducting wire, just allow some electric current to pass. When electric current start flowing through the conductor, then that conductor will show magnetic property. This is nothing but Ørsted has explained as magnetic effects of electric current. Understood? Understood? Fine. Now, next one. Listen carefully. Magnetic effect of electric current. Children, what do you mean by magnetic effect of electric current? Listen carefully. When an electric current is passed through a conducting wire, a magnetic field is produced around it. Am I right? So this is the concept which Ørsted also explained, children. Children, everyone, please turn on your video. Please turn on your video, everyone. Fast. Yes. So children, what do you mean by magnetic effect of electric current? It is nothing but when an electric current is passed through a conducting wire, then magnetic field is produced around it. Any doubts? We'll do those experiments. Before that, I'm just giving some introduction. Now, children, what do you mean by compass needle? You guys see in compass needles, right? So what do you mean by compass needle? I think 10th standard students have some experiments in your lab regarding compass needle, right? I hope you guys done that. So children, what do you mean by compass needle in reality? The presence of magnetic field at any point around the current carrying wire can be detected with the help of a compass needle. Children, you just consider through a conductor, electricity is passing and it produces magnetic field. That magnetic field you guys are unable to see, right? You guys are unable to see magnetic field. Then how you guys will understand the presence of magnetic field around that conducting wire? For that purpose, we introduce a compass needle, children. So the compass needle will get deflected because of the presence of magnetic field. That deflection, everything we'll discuss during our class. Okay, so listen carefully. What do you mean by compass needle? Compass needle is nothing but the presence of magnetic field at any point can be detected by using this particular device. Fine. Now, in the absence of magnetic field, what happens to compass needle, children? the compass needle will rest. So that resting will be along north-south direction. Why? Why it rests along north-south direction? Children, I already explained what do you mean by compass needle, right? What do you mean by compass needle? It is just a device which is used to detect the presence of magnetic field. Whenever there is the presence of magnetic field around a conducting wire, you can detect that by using a compass needle. That means that compass needle will show some deflections. Now, children, in the absence of magnetic field, what happens to the compass needle? It will be in rest. There won't be any deflection. But that resting also along north-south direction. Why, children, that particular compass needle will rest along north-south direction? Children, the reason is nothing but Earth magnetic field. The reason is nothing but Earth magnetic field. Children, see here, I have a conducting wire you just consider. This is just a conducting wire you just consider. Now, here electricity is passed through this conducting wire. So if I introduce a small compass needle, what happens? It will show deflection. Now, there is no conducting wire. There is no magnetic field. Then also this compass needle will show deflection towards north-south direction because Earth magnetic field presence will be there, right? So you guys will have a doubt. Sir, if you introduce a conducting wire, that means electricity is passing through the conducting wire, then what is happening? That condition also, this Earth magnetic field will be active, no? Yes, children. It will be active, but it won't make any difference here because if you introduce a conducting wire here, this field will be much stronger than Earth magnetic field. Understood? So children, if you guys are introducing a conducting wire, then that condition also there will be Earth magnetic field. But the compass needle won't detect that because that magnetic field will be, that strength will be very less. But if we introduce a conducting wire nearby that compass needle, then that strength, magnetic field strength will be very high. Because of that reason, it will show that particular deflection only. Understood, everyone? Any doubts? Fine. Now we are going to introduce Oersted's experiment on magnetic effect of current. Children, already I explained what was Oersted's analysis. The Oersted already explained that whenever there is a passage of electric current through a conducting wire, the magnetic field will be produced. That means magnetic effect of electric current. That was a concept was introduced by Hans Oersted. So we are going to do that experiment. Children, we are going to perform that experiment. Listen carefully. So the first case I am going to introduce. You can see one circuit here, right? You can see one circuit here. In the circuit, you can see this is nothing but a rheostat. This is nothing but a rheostat. Here, this is nothing but a key. And this is nothing but compass needle. Can you see everything? So children, listen carefully. Here the key is open. So this is an electric circuit and the key is open. So the electricity will pass through the circuit. Will the electricity will pass through the circuit? No. So since the key is open, the electricity will never pass through the circuit. That means the electricity won't pass through the conducting wire AB. So when there is no presence of electricity, what happens to this conducting wire? It will produce magnetic field? No. It is just a conducting wire. Am I right? If there is presence of electricity, then only that particular conducting wire will produce magnetic field. Whenever there is no passage of electric current, then what happens to this conducting wire? It is just a conducting wire only. It won't produce any magnetic field. Understood? So in this circuit, you can see, children, the particular key is open. Because of that reason, electricity passage is blocked. The current will not pass through AB. Now we can see that the compass needle is resting in along north-south direction. Why it is resting needle points in north-south direction, children? Because in this moment, only one magnetic field will be active. That is nothing but Earth's magnetic field. Right? Under this condition, only one type of magnetic field will be experienced by compass needle. That is nothing but Earth's magnetic field. Understood? I hope you guys understood. Fine. Now, everyone, please listen carefully. We are going to discuss the second case. The first case is nothing but when the key is open, no electric current is passed through the circuit. Hence, through the wire conducting wire AB, there is no passage of electric current. Hence, it will not produce any magnetic field. Am I right? Because of that reason, the particle compass needle will rest along north-south direction. Now, that problem is solved. Now, we are going to introduce electric current. The current circuit is connected perfectly, children. So the circuit is closed now. So electric current will pass from positive to negative like this. Am I right? The electric current will pass from positive to negative like this. Am I right? The current will pass from positive to negative. Already in current electricity chapter we discussed. Now, children, under that condition, what happens to the compass needle? The compass needle, the north pole of the needle deflect towards west. What is the reason behind the children? Children, listen carefully. This one you should refer. Okay, this particular directions you should refer. Now, we understood when electric current passage started, the electric current is passing through the circuit. Under that condition, the compass needle was earlier resting along north-south direction. Now that particular compass needle deflected towards west. What is the reason behind that, children? What is the reason behind that? Children, listen carefully. Listen carefully. After that, you can write notes. Children, this is just the diagram, isn't it? The geographical map. Just listen carefully. This is nothing east. This is nothing west. This is nothing but north. This is nothing but south. So when there is no passage of electric current, what happened that condition? Simply it was resting like this. Simply the needle was resting like this. Am I right? Compass needle was resting like this. This is north, this is south. Just earth magnetic field was acting. Now, when the electric current start flowing through the conducting wire AB, what happened? What happened? This particular magnetic field becomes strong. The strength of this magnetic field become strong. Because of that reason, this side it will get north pole, and the other side it will get south pole. That means, children, here north pole, here also there will be geographic north pole. This two north pole will deflect. Because of that, two north poles are there. Because of that repulsion, this particular compass needle will deflect towards west. Like this, it will deflect. Am I right? Arthur, understood?
Yes, sir.
So when there is no passage of electric current, the particular compass needle was resting along north-south direction. That time there is no repulsion. Why? That magnetic field strength was very less, right? Now the electric current passage started through the conducting wire AB. The electric current started flowing. Then what happened? The magnetic field strength increased. So both the polarities are same now. North pole and the geographical north, both of them are coinciding together. If north pole and another north pole, that means same polarity, means they will undergo repulsion. Am I right? Because of that repulsion, this particular magnetic needle now directed towards the west. Now let me ask one doubt, children. Why it is directed towards west? It can repel any direction, right? It can repel towards east also, right? Anyway, repulsion is happening. Then why this compass needle deflected towards west? The reason is nothing but, children, here the electric current is passing like this now. The electric current passage is like this now, positive to negative. So there is the force is acting towards in this direction only, right? So that repulsion happen in that direction towards west. Understood, everyone? Sia,
Yes,
Ishita,
sir.
understood? Fine. Now I'm going to increase the current in the circuit. I'm just going to introduce one more battery. Then what happened? The electricity inside the circuit will increase. The current which is passing through the conducting wire AB will increase. Am I right? Then what happens to the deflection? The deflection also of the needle also increased. Understood? So please understand, children. First experiment, he just introduced of an open circuit. The compass needle was resting in north-south direction. Now he introduced one closed circuit. Now, because of the closed circuit, the magnetic needle is able to experience the magnetic field. The compass needle was able to experience the magnetic field. Because of that reason, it deflected towards west. Why it is deflected towards west? Because electric current passage is through that direction only. Because of that force, it deflected towards west. Now I'm going to increase the electric current. Then what happened? Then the magnetic needle will undergo, or the compass needle will undergo more deflection. Understood, everyone? Any doubts regarding case 1 and case 2? Is it okay? Fine. Now, we are going to discuss case 3. What is case 3, children? When the current is reversed and the compass needle kept below the wire, what happened? When the direction of current in the wire is reversed, the north pole of the needle deflect towards east. How it is possible, we need to check, right? So listen carefully. I'm going to draw that circuit. So this is nothing but my circuit. Now the current direction reversed. That means earlier it was positive, negative like this. Now it changed. This is negative and this is positive. Understood? Now like this, it's going on. Now our compass needle is, we have the compass needle, right? This is nothing but our compass needle. The compass needle is in rest. You consider the compass needle is in rest. So what happened? This is nothing but north and this is nothing but south. Okay, like this electric current passage is happening. Fine. It's a closed circuit, but in the beginning stage, what happened? The compass needle is in rest. Okay. Now electricity passage is nothing but this is positive, this is negative. So electric current will flow from positive to negative. So like this electric current will flow. Am I right? Like this electric current will flow. Now children, just write geography directions. W, this is east, this is nothing but north, and this is nothing but south. Okay. Now children, the magnetic needle is resting like this, or compass needle is resting like this at initial condition. This is nothing but north. Okay, no problem. Now, close the circuit. During that process, what happened? The electric current will pass from positive to negative. That means the electric current passage is from B to A. If you consider the conducting wire, now electric current will pass from B to A. Still now it was passing from A to B, right? Now we change the polarity. Because of that reason, now the passage of electric current is from B to A. Understood? B to A. Then what happened? If it is passing from B to A, what happened? The magnetic strength is more now. So here, the strength of the magnetic field is more. So it became north. Okay. This side became north in direction. Now the electric current passage is like this, right? So see here, both of them are in, this is north pole, this is north pole. Both will repel. Am I right? So that repel, because of that repulsion, they should move. The needle should deflect. Here, electric current passage is like this. So because of that reason, it will repel towards east. Understood? It will repel towards east. That means like this, the circuit, like this, it will become. Understood? This will be north and this will be south. Understood? Everyone understood? Once again, sir will explain this circuit. Children, here the polarity of current we changed. Now electricity is passing from B to A. In the beginning stage, the compass needle is at a rest. When electricity passage started, what happened? The strength of the north pole increased. Understood? The magnetic field strength increased. Hence, the two north pole we have, right? The geographic north pole and compass needle north pole. Both of them will repel. Now, according to repulsion, it should deviate, it should deflect in any direction. Since the current is passing from B to A, towards that direction the force is acting. Hence, now this compass needle deflected towards east. Am I right? I hope everyone understood the concept perfectly. Is it okay? Fine. Now, the remaining four, case 4 is nothing but very easy. This is things you just understand. Okay. If the compass needle is placed just above the wire, then what happened? The north pole will deflect towards east when the direction of current is from A to B. That means the polarity again changed. Now the polarity, that means the first stage you just consider positive to negative. Under that condition, you're just keeping that you just consider positive to negative, like this current is passing from A to B. Under that condition, you're just keeping your compass needle just above the wire. Then what happened? The north pole will deflect towards east only. Understood? Understood. If you want, I'm ready to draw the circuit also. See, like this. This is positive, this is negative. Like this, you have compass needle, you guys have like this. Okay. Under this condition, what happened? This is positive, this is negative, means electric current passage will be like this. Under this condition, you're keeping the compass needle just above the wire. Then what happened? The north pole will deflect towards east. Understood? Now another condition, case 5. The compass needle is placed just above the wire. The needle deflect towards west if the direction of current is from B to A. What do you mean by that? Now I'm changing the polarity. That is nothing but this is negative, this is positive. Like this, it's happening. Now, this is nothing but your compass needle. You just consider like this, okay? Now, polarity of current change, children. And now the electricity is passed from B to A, right? The electricity passage is from B to A. Under that condition, if you keep your compass needle above the wire, the needle will deflect towards west. Fine? Fine. Okay, now I just want you to recollect what all things we discussed. The first condition is nothing but, everyone listen. The first condition is nothing but, you have a circuit. Now electric current is passing from A to B, but the circuit is an open circuit. Because of that reason, electric current passage is not there. The electric current passage is not there. Now what happened? The compass needle will rest in north-south direction. That means earth magnetic field will be there. Now, the electricity passage starts. The electric current will pass from A to B. The electric current will pass from A to B. That means anti-clockwise direction. Under that condition, what happened? The geographic north and your compass needle north, both of them will repel. Because of that reason, the compass needle will deflect towards west. Fine. Now, third condition, you're going to increase the current inside the circuit. Then what happened? The compass needle will deflect more. So when the electric current increases, the magnetic field also increases. That is the meaning. Third condition, you are going to change the polarity. Now electric current passage is from B to A. Under that condition, also this compass needle and geographic north will experience repulsion. But now the direction of current change from B to A. Because of that reason, that deflection is towards east. That is the fourth condition. So third condition. Now fourth condition, children. Fourth condition, electricity is passing from A to B only. But now you guys are keeping the compass needle just above the wire. Just above the wire. Then what happens? The deflection, the compass needle will deflect towards east. Opposite that you consider. Now electric current is passing from B to A. You're keeping the compass needle just above the wire. Then what happens to the deflection? The deflection will be towards west. I hope everyone understood Oersted experiment. Fine. Now children, please understand this. So we done the Oersted experiment, that is nothing but magnetic effect of electric current. Now, what are the conclusions we arrived from that experiment? What are the conclusions we arrived from that particular experiment? Children, the first conclusion is nothing but, when electric current is passed through the conducting wire, a magnetic field will be produced. Now, when the magnetic field is produced, then what happens? That magnetic needle inside the compass will experience a torque. What do you mean by torque? The rotating force, we call it as torque. It is just a force only. Understood? The force is revolving like this, or force is rotating, that we call it as torque. Understood? So you guys please understand, children, whenever there is a passage of electric current through a conducting wire, then magnetic field will be produced around it. Now, because of the presence of that particular magnetic field, the magnetic needle, that means the inside the compass you have a magnetic needle, it will experience a force, that means a torque. Why it is experiencing the force? Because of the deflection, right? Because of the repulsion, it is able to experience that deflection. Understood? Now we are going to increase the electric current in the wire. Then what happens? Then the deflection of compass needle also increases. So the strength of magnetic field around the wire also increases. What do you mean by this? So when the electric current passage increases, more electric current if we allow to pass through the wire, then more magnetic field will be produced. Third point, if you reverse the direction of current in the wire, then the magnetic field also will be reversed. That means if the current passage is reversed, then the magnetic field passage also, the production of magnetic field also will be reversed. Understood? These three conclusions, I hope everyone understood. Any doubts? Come back, children. Magnetic effect of current. This is the conclusion. So from Oersted's experiment, we understood certain facts, certain concepts. Now we are going to conclude that. So a current or moving charge produces a magnetic field around it. That means through a conducting wire, if you pass electric current, it will produce magnetic field. This is what we call it as magnetic effect of current. Next one. The strength of magnetic field depends on the magnitude of current. That means when the current increases, the magnetic field will increase. When the current decreases, the magnetic field will decrease. The direction of magnetic field, that also depends upon the direction of current. You already remember now, when the current passing from A to B, based on that needle show one deflection towards west. When the current is passing from B to A, the compass will show deflection towards east, right? So the direction of magnetic field depends on the direction of current. From all this, we understood current is the hero here. Understood? Without current, no magnetism. He is the hero. For electromagnetism, current is the hero. Understood? Yes.
Sir, I'm hearing current is the hero. Current is the hero.
Current is the
Current.